Welcome to the Web of NAME, exploring the connectivity and expanse that is the NAME Programme Grant. Key connections to the grant are made with the work packages of underpinning capabilities in green, of nanoscale advanced photonics in orange, energy engineering in blue, and materials for quantum in red. Further connections to NAME have been made in yellow. We have three key institutions. Firstly, the University of Manchester. PNAME, the platform for Nanoscale Advanced Materials, is one of our key tools, providing a route for localised doping and single ion implantation. This single ion implantation is key for the deterministic ion implantation for qubit generation, but the projects benefiting from PNAME are not only within the key institutions but far-reaching, including the University of Oxford with the creation of colour surface in diamond. The creation of novel sources crosses both Imperial College London, where they are created, and the University of Manchester, where they are utilised. This strengthens the position of NAME in delivering unique ion species for ion implantation via focused ion beam technologies. Validation of single ion implantation is key, and while employing techniques in-house, we are also expanding our possibilities, including STM in collaboration with NPL. In-house confocal microscopy at Imperial plays a large part in observing these low-dosed areas. We are not limited to low dose, with silicon enrichment being a key area of research within the grant, but already being utilised by 4 collaborators around the world. Delving back into single ion implantation, characterisation is also taking the form of transmission electron microscopy, TEM, giving further evidence as to the location and density of implanted regions. High-dosed areas have also been investigated for their post-anneal properties, including the localised generation of gold nanoparticles used for X-ray enhancement. And this localised nature of the beam also gives rise to the ability to test as-grown morphologies against those ion implanted. The depth of single ion implantation and low-dose ion implantation is evident in the in-house and external collaborations. The development and control of topological states plays a key role in achieving our goals and connects the University of Manchester and the University of Leeds, as does the creation and characterisation of spin currents of active interest in energy engineering of the future. Photonics are a key area of research, with silicon-based photonics being an active area of research focused on the University of Manchester, but with many projects also leading to other external connections, which are strengthened by the research being done by NAME. The photonics areas are wide-ranging, including localised doping and strain engineering. Custom is another one of our key tools for the characterisation of localised dope by terahertz SNOM, located at the University of Manchester. This system can be used to characterise the various topological insulators that are being made at the University of Leeds, as well as more nanoscale structures such as nanowires. TEM is not only used to confirm the single ion implantation, but also in-situ heating allows for the characterisation of the effects before, during and after the heating process. Through the NAME Programme Grant, there is also development of new capabilities, such as the UK-based EDMR setup, to observe the magnetic resonance of the species implanted at low dose, and the optical microscope, which is optimised to assist in the fabrication and characterisation of quantum photonics. We've already mentioned our second key institution, the University of Leeds. This is home to the Royce deposition system, where the deposition and structural characterisation of topological structures and films occurs, but also research into the control of direct plasmons and gate-controlled surface states. All device fabrication is supported by the cleaning facilities housed in the University of Leeds and also Imperial. Also housed at Leeds is the Poloid Terahertz Institute, enabling terahertz characterisation of many different devices that are embedded into the NAME Programme Grant. And finally, Imperial College London houses its own unique facilities, including atomic probe microscopy, deposition of thin film for plasmonic applications, arc furnaces used in the creation of novel alloys, and the confocal microscope used in looking at the low-dose defects and research into new novel laser technologies. As you can see, the breadth and strength of the NAME Programme Grant is extensive and is supported by all 3 institutions, furthering their collaborations and creating the Web of NAME.